Hello, I hope you got a chance to complete the hands-on exercises on variables and literals, which you should have got some idea about getting started with programming. Now, in this chapter, we will go ahead with type conversion, casting, and look at how the automatic casting rules are applied in Java and what are the implicit conversions which is basically done by the Java programming environment. But before going to this chapter, please ensure you have completed the hands-on exercises. In case you have not done, as usual, please pause the video, complete it, and then continue. Let us explore type conversion and casting features we have in Java and look at different scenarios, look at different behaviors exposed by the Java runtime environment and also during compilation. So let us look at conversion of two types. So especially when we are talking about conversion, we are talking about data which can be compatible and can be convertible. So this is very much important because you cannot convert a string directly into an integer. That will not work. It will throw in an error anyway. But if you have a long and int, for example, integer, so there is a way in which you can convert, and there are different conditions and different behaviors, and that is what we are looking at in this particular chapter. Okay, so let us look at automatic conversion behavior when the two types are compatible and convertible. So this is the place where automatic conversion will happen, and we do have another concept called widening conversion in this situation. So let us look at a destination type which is larger than the source type, which means it's very simple. Let's take an example of int I is equal to 10 and long j is equal to I. So which means we know long is the destination here and it is larger than int because the range of long is much wider. So in this case, definitely it's like a larger cup holding the contents of a smaller cup, as simple as that. All right, so it's very much possible. I can just pour. Let's take an example. I have a half-liter cup and a 1 liter cup, and I want to pour the contents of half-liter cup to 1 liter cup. Very much possible, and that is what is this widening conversion is all about, where Java automatically supports using the long j to be used as representing an integer value, and it very much works, which is pretty obvious. Next, we'll look at the second type of conversion where you're trying to cast two incompatible data types but convertible. Okay, so let us look at exploring this scenario of the situation where the destination type is smaller than the source type, but they are not compatible directly. So where you see here, you have integer j is equal to 5 and you're directly equating j, which is integer, to be, oh, okay, there's a small typo here, so let's consider this as j. Okay, so you have byte b is equal to j. So this cannot work directly because we know this is a bigger jar, right? So integer is a bigger jar, byte is a smaller jar. So directly you cannot use it because it might result in incompatibilities. So if you try to pour, say for example, 1 liter of jar which is having 1 liter of water and pour it into a half-liter jar, for example, you know that there could be a spill out and overflow of water. So this is what happens even in a computing environment. So when you are basically requiring to do this explicitly, you have to specify that I'm okay to lose the additional water. Makes sense? So in this situation, you could see that we have a casting option available and it has to be specified within parentheses. So when you give this, the compiler will understand that, okay, this is given by the developer and it's developer's responsibility or your responsibility as a programmer. Okay, so in this situation, compiler will do allow and Java will say, okay, you have asked for it, okay, I will give. So it will say, okay, straight away pouring the contents of 1 liter to half liter is not a good choice, but what if I have only say 100 ml of water in the 1 liter can, okay, 1 liter jar, and I'm putting it into a half liter jar, it still works because there is only 100 ml and I'm pouring it into the smaller jar and it still works, and that is what the condition. So with a caution, and that is what with the casting behavior Java allows. So when you know that it is okay, you can basically see that you can convert it into byte and it will work. Now comes the question, when I have 1 liter water jar with say 750 ml of water and I am trying to pour it into a 500 ml jar, half liter jar. So definitely, even though I am saying it's okay to do, we are having the risk of overflowing the content. So right, the same behavior is called as narrowing conversion. So where you see that the destination type assigned is smaller than the source range. So in this case, what happens, int k is equal to 260 and you are trying to convert this into byte. So directly putting this as byte b1 is equal to k will not work because it will throw an error. So programmatically, as a developer or a programmer, you need to specify this by again a cast. But when you do this casting, there is no error, but logically it would see that there is some kind of a narrowing conversion that has happened, and after that integer value, say for example the byte value, what happens is it will just take data that is basically there and it will narrow down, and whatever is left over it will automatically consider that as the value. We will see that in the hands-on exercise to help you get more clarity. So we'll see that in the next chapter, how the hands-on work and what is the output that you can expect when you do this. And then we do have the second option where the truncation can happen also. So when the compatibility is there, say for example, if you are putting a floating point value is assigned to an integer. So this is another place where you are trying to host or put this information into a float. Next is truncation. So here you are trying to put the value of a floating point number into an integer. So here you would see that you have a floating point variable, say float f is equal to 12.23f, and then you are putting directly into an integer. Here casting is not required. What it will do, it will chop off the decimal portion and consider only the integer portion. So this is automatically taken care by Java. So this is another thing called as truncation. So when you have these incompatible types, these are all the different behaviors exposed by Java. Then we do have another feature called automatic type promotion, especially in expressions. So when you have an expression where you would see that, say for example, like byte by1 is 55 and then byte by2 is 45 and 3 is 100. And you have an expression where you are saying byte 1 star or multiplied by byte 2 divided by byte 3. So this actually exceeds the bytes capacity because byte range has 2 to the power of 8. So it exceeds this capacity. So you have an option where it can automatically be converted into the next range. And if you write a program where you are directly equating this to an integer, it still works. It's like automatically promoting to the next range, and this is done automatically by Java. However, if you see that instead of integer, if you have kept the same byte, for instance, so you will get that you have an error. So you will definitely see that if you try to equate this to byte only, you would see that it might overflow. So you will get that error, and you would see this. Say for example, you have byte b4 which is 125, and then you are saying that byte b4 into 2, which definitely exceeds the range, and you are trying to equate to same byte, it will throw an error. So if you really want, you have an option to either make it to as an integer. Alternatively, you have an option to do a typecasting where it will apply the narrow conversion rule automatically. Next, we do have a summary of the type promotion rules that are supported in Java. So the whole expression is promoted to an integer if the operand contains byte, short, or a character. So when you have these types, by default, it will convert it into an integer. Next is that whole expression is promoted to long if one operand is long. Say for example, if you're adding integer, byte, and long. So the total thing should be long, which is pretty logical, and that is what is the behavior in Java. Next, whole expression promoted to float if one of the operand is float in an expression. So this is also obvious. So if you are saying integer and multiplied by a float, the resultant will be float. It will not do any truncation or do anything. It will directly say that, okay, you are saying float into integer, it will return float. So this is automatically taken care by the promotion rules in Java. And similarly, if you have a double in your expression, the whole expression is converted into double. So even if one of the operand is double. So which means Java looks at the different types that are there and looks at the maximum or highest range in its operand and considers that as the answer for its promotion. So that's a basic behavior we see in Java. So this completes this chapter of type conversion and casting of features. So it's a very important concept. And next we have a hands-on. So it's a very important hands-on and an interesting hands-on to understand the behavior, and sometimes you also get the errors when you don't code it properly with the proper casting. So we'll just explore these things in the next hands-on exercise.